type of normalization technique that's called min-max normalization. So in this technique of data normalization, linear transformation is performed on the original data. So minimum and maximum value from data is fetched and each value is replaced according to the formula. So that's what you know your min max normalization. You have to fetch the min and then max. Once you fetch the min and max, and each time for each value you have to apply the specific formula to get the to normalize the old data. V minus min of a divided by max of a minus min of a, and new max of a minus new min of a plus new min of a. This is what the formula that we apply here. Let's do a small example so that it would be very clear. So min max scaling, min max normalization. So import pandas as PD. Then let's take any data frame. df is equal to pd dot read csv, and I'm gonna go for the soccer players data. So df, okay, this is what my data, and I want to weight in kg. So this is the data I just want to normalize. I just want to normalize that one. So let me take perform a min max scaling on a specific column. So column name I'm gonna take as, let me directly copy from here. It's a weight in kg. Yes, it's done. Now let me apply the formula one by one. So I want to add a new column to that. The new column name is weight normalized. Weight in kg normalized, and is equal to, now let me apply the formula. So df of, so weight in kg minus df of weight in kg, and apply a min and divided by, let me apply the max min formula here. Yep. So df of weight in kg dot max minus df of weight in kg, and let me apply the min here, and that's it. Now formula is ready, and let me execute and see what will be the condition. And if you want to see the formula again, so weight kg normalized, the new column is with this formula. Yep. So df, and here is your normalized weights, 0.2, 0.1, 0.8, and similarly I will convert this height also to the same scale so that I can do the respective calculations with that very easily without any tampering with their without any without spoiling the overall calculation. So let me do the same for height in centimeter. Let me bring down to the same scale. Height in centimeter. Let me copy from here directly. Height in centimeter. Height in centimeter. Height in centimeter. Height in centimeter. And here the final one. Height in centimeter. And now let's look into the data frame. Yes, here is that. And you can see that weight normalized, height normalized, and the proper scores, these are called normalized scores. And with this normalized score, you can take up any weightage and you can do a calculation. So we have used it, but we did not use the min-max scalar. We used a normalized, that g-score scalar in our recent project. Okay. And this is an hard coding. If you just want to use a specific method from a scalar, we can do that too. Let's use that way. So import pandas as pd, then we have to bring min-max scalar from a pre-processing module, which will come from sklearn. So sklearn dot pre-processing, and import min-max scalar. So min-max scalar has come. Now just for sample, let's take any data frame, or else let me take df players is equal to, what's that, sorry, pd dot read csv, and it's called, now what's this data we have used? No, I'm gonna use customer data. Okay, so here I'm gonna change this to so yes, this is what my data. So this one I just want to price is the one which I want to convert, which I want to normalize. So what I'm gonna do now, let's perform min max normalization on columns age. Okay, let me do age also. I can do the both, or I can do anyone. That's okay. I'll do it on price. Okay, so for that, first one, scalar is equal to, I'm using min max scalar, so normalized price is equal to scalar. So I'll have scalar dot fit transform, and then the data frame here is, so I just want to take the one, so it's only one, so cust, and it's price. So expected 2D array got 1D array. Could not convert a string to float. That's okay. So that's what the scalar min scale. So next what I'm going to do here is Let me take df is equal to pd data frame, and then as usual, yeah, and so let me put the here. So normalized df is equal to scalar dot fit transform df, and then so let me call for the normalized df, that's is equal to pd dot data frame normalized df, and then columns is equal to df dot columns, all columns. So and finally print normalized, sorry, print normalized df. And this is how you normalize this data, and you brought the both the data at the same scale. And let me make it 76, 99, and you see that still they're on the same scale, still they're on the same scale, and it would be easy for us to do calculations. Okay,